which you provide the input files as part of the constructor. Then you can call an API to push the description of this data set, compile, and store it. It's quite simple. And regardless of which method you use to create a UDF and attach it to an HDF5 file, you end up with a metadata that looks like this. You have a JSON-like object. You have a description of which backend needs to be loaded at execution time. You have any dependencies that your dataset has. In this case, we have an X-ray input dependency. Here is the output that we are creating. We're just computing the negative logarithm of this given input dataset. So that's the name we're giving to that dataset, and so on. So we have the output resolution, the data type. Everything is encoded on this metadata block. Then when it comes to looking into what can be done with HDF5 UDF, I have selected a few interesting use cases. So in this very first one, you have methodology to generate or to virtualize data, if you will, data that's stored under different formats. In this slide, on the topmost part, you see a hdf file. We're calling it srtm.tif. So this UDF is reading the first band of that file, and then it's copying the band values to the HDF5 dataset that the calling application has opened. And this is performed on the fly. So any changes that that user may want to make to the underlying TIFF file is going to be automatically reflected when the application reads the same data through HDF5. So we are basically bypassing, right? We are just having a pointer to the actual data that started on a different format. On the bottommost part, we have an example showing how you populate a compound data set from a CSV file. We are parsing the contents of the CSV to determine the values of 3 members of that compound. We're calling it timestamp, value, and event. So quite simple. Again, we are having this framework that allows us to do something that was not possible before, right? So you can modify values of the CSV on the fly, and each time you read the HDF5 file, the updated values will be provided to the application. Another example, very similar to the one before. In this case, we both open data from a TIFF file, but also we reproject data from that TIFF file into lat-long using this library called RealX-Array. So very similar, but it's showing you a different use case. In this case, we're dealing with data reprojection. We have another use case you may want to use. Say you have a lot of data you want to provide to a machine learning model. You do not have enough samples, so you may want to resort to synthetic data sets. So you may use conditional GANs, for instance, so that you can create new values given a trained model. In this case, we're loading from a file called generator.h5. We are then producing one sample, and then we are just populating the contents of the output data set with the predicted or with the generated data from that conditional GAN. Another example is the virtualization of remote data. In this case, we are resorting to a database called CXIDB. It's a coherent X-ray imaging data bank. And what we are doing is we are downloading a data that this server hosts. It's an HDF5 file. We download it using the requests Python library. Then we just use H5Py to extract the data set of interest, and then we just update the output dataset values with that data we just retrieved from the internet. We have another example here. We are just downloading data from a web service. In this case, this is a web service that provides you real-time data from the weather radar at Chicago International Airport. So we're accessing this web map service. We are requesting a given layer of that service. We retrieve it. We also create a lookup table so that we can print the data using colors on our utility here. So this is the kind of thing you can do with HDF5 UDF. So you can resort to services that may be behind a web service, may be provided by a sensor. So this is just to give you an idea of the kind of flexibility that this framework gives to you. So now that I have shown you what this platform can do, we can finally go back to the original problem of data storage consumption. So while contiguous datasets and chunked datasets require more storage as the underlying data grows, UDFs are just bytecode, right? So we are quite humble when it comes to storage needs, and it almost feels like we're back in the 1990s because we are just talking about kilobytes versus several hundred megabytes or sometimes gigabytes of required to store each data set. So last but not least, this utility is supported by the 3 major operating systems, so that you can give it a try regardless of which one you are running on your machine. This is the URL, so you can take a look at the project, and I am happy to take any questions that you might have. Thank you so much for your attention.
All right, thank you. Fascinating stuff. Any questions for Lucas? Oh yeah, hold on. Here's a question.
Hey, Siri speaking. Actually, you had a notion there on one slide that you are storing like machine learning model within HDF5. Did I see that correctly?
Yep.
Yeah. Yes. Yeah, so how does that actually look like within that file? Just if you can briefly, or maybe we can talk offline. I would be interested into that.
Oh yes. This is actually you're basically storing the data that the GAN has produced as a data set. So you actually have a lot of metadata. I can share some of that with you if you can give me your contact, or you can just drop me a message at lucasvr@ibm.com.
Any other questions? Oh, there's one more question.
Yeah. On your example with the using C++ to express this UDF, you said that you compile that into a shared library. How do you deal with that? I mean, you store what in the HDF5 data?
Yeah, so basically in this example, so what you have is this utility, command line utility, for example. You are providing a CPP file to this utility. It's going to take this recipe or this script, if you will. It will compile it into a shared library. And then that's what we store on the metadata field of the HDF5 dataset. So basically what we are doing here underneath is we are using the IO filter interface. So if you look into this example here, IO filters are usually used to compress data, right? So you have the input, in this case, a grid. You compress it using some algorithm, and then you store the compressed data on disk. And then when the application reads the data, we decompress that data, right? With HDF5 UDF, we actually execute the compiler step inside this compression box. So this is the magic. We are using IO filters. So the compiler creates a shared library that's actually stored on disk as if it was the compressed form of the script. And then when the application reads the data, instead of decompressing it, we just load that shared library from disk, and we DL open and execute the function, the entry point function that the user wrote. And that's what's going to populate the dataset values on the fly.
Okay, thank you.
Lucas, you didn't mention it, but if security is a concern, you saw that everything is digitally signed and so forth. So there is that.
Yes. Yes,
Yeah.
yes, that's right. So this mechanism that allows the execution of the UDF, it is actually protected by a sandbox. So we basically we have some rules. So for as you have seen in this slide where we have the UDF metadata, each time you create a UDF, we attach the public key of the user that created it, and this is handled by HDF5 UDF, both the creation of a private key and the attachment of this public key to this UDF. So each time you execute your own UDF, you have access to everything you would have as a regular user on your machine. If you're reading, if you're receiving a data set from a third party, you're not going to have a data set that has free access to your machine, right? You're going to have a different public key than yours. So we validate the signature of each of the data set prior to its execution, and then we have a simple mechanism in which you can associate public keys to access rules. So you may say, hey, this user, this public key is only allowed to say allocate memory, use malloc, and nothing else. If the UDF executed or created by that public key attempts to do something else, like accessing a file on the file system, then we kill the process, and it is not allowed to execute those accesses that are not allowed. So this is enforced by HDF5 UDF at runtime automatically.
Okay, thank you. Great talk.
Thank you.
Thank you very much. Which brings us to the last. Oh, there's one more question. Hold on.
Hi. Yes. You mentioned some dependencies in Python. You can import external libraries.
Yes.
And is there any way to specify this dependency link when you execute the code? And if the second question is there the same thing for C++ or just for Python?
Okay, good question. So you're referring to, say, requirements.txt file, which gives you the list of dependencies so that one can pip install them? If that's what you had in mind, there is no support for that kind of description yet. The Python backend we have is very simple. It is just one backend that loads bytecodes and then just executes them. So as you see, this is what we're calling the CPython backend. We could have another backend which just extends this one called, say, CPython plus pip, which would have more metadata so that those dependencies could be installed at runtime if they are not present. But for the time being, we just assume that the target machine has all the dependencies needed to run the bytecode to completion. And the same applies to C++. We just assume that all dependencies are already installed. We do not attempt to carry over everything. But having said that, in another HDF5 users group meeting we had, I have shown you that it is also possible to have some very interesting UDFs. For instance, you could have a virtual machine that executes each time you read a data set. So you could have all the dependencies you need inside that virtual machine. So you could bring an entire operating system, a very complex set of dependencies, and you just load that virtual machine from a blob, from a binary dependency that you would have on the same file. So it is possible to today, using this infrastructure we have, to have a self-contained executable, if you will, inside HDF5.
Okay, thank you very much. Very interesting.
Thank you.
Thanks again.